So now we will start with the next topic, that is the interconnection and signal integrity. Here the term signal integrity refers to the degree to which the effects like distortion of the signal and the noise are minimized. So here, if I use a PLDs, we need to control the signal integrity properly. Similarly, if I using ASIC, here responsibility for signal integrity must be taken. So here we'll focus on the PCB design. So the major signal integrity issue is in PCB design, which is nothing but ground bonds. So ground bonds which arises when one or more output drivers switch the logic levels. Okay, switch the logic levels means when there is a transition takes place from logic 1 to 0 or from logic 0 to logic 1, then the ground bonds appears. So it appears when the current flows from power supply to ground. So it is also called as a phenomena in which when a gate voltage occurs less than the local ground potential, which causes unstable operations. This is also known as ground bonds. Now we will discuss few topics which involved to reduce the ground bonds. So they are, first one, inductance in the bond wires, package leads and PCB connections for power and ground. Second, overshoot, undershoot and ringing transmission line effects. Third, differential signaling. So first we will discuss how to reduce the ground bonds with respect to signal integrity. So in that, this is the first topic. Here in the circuit diagram which is shown here, so it consists of a logic function which involves some inverters and with a symbol here. So here in this circuit diagram, we will only focus on how the ground bonds appears when there is a transition takes place from power supply to ground. So now here we will concentrate on power supply plus V volts and the ground here. So at the power supply, there is the PCB inductance is connected also at the ground potential. So this inductance, when there is a transition from plus volts to ground, this inductance produces a voltage spikes or the current spikes, depends on the transition. So these spikes will distort the signal integrity or reduces the signal integrity. So now in other words, we can say that we have to reduce the inductance between the plus volts and the ground. If we are capable of reducing the inductance, then signal integrity can be increased. Here the inductance are used just to block the AC components and allow the DC components, because these logic circuits which are implemented in this IC package only works for the DC. So that's why the inductances are used here. So now inductances must be used. So but due to inductance, we are getting the ground bonds. So that ground bonds can be reduced with the following steps. The first step here is, if we connect a coupling capacitors or a bypass capacitors across the plus 5 volts or the ground. These bypass capacitors can reduce the voltage spikes by charging at the plus volts or the ground. So which is explained here. Okay. Here we know that the inductance causes the voltage spikes between the power supply and ground. So this effect can be reduced when we connect a bypass capacitors between the power and ground. So thereby it holds the reserve charge, okay, which appears like a spikes between the plus volts and the ground. When we reduce the spikes by the bypass capacitor, thereby it reduces the inductance. Okay, that is the first way. The second thing here is by connecting a separate layers for the ground and the plus volts, which is shown here. Here in the second step, we have shown some layers here. Seen the signal layers, power plane layers and the ground plane layers. If we use a separate PCB layers for the ground and power supply, again this gives us low inductance path, thereby reducing the voltage or current spikes. Thereby it increases the signal integrity. The third is, we can minimize the slew rate. Slew rate is nothing but here the maximum rate of change of voltage with respect to time. So if we are capable of reducing the slew rate, nothing but is shown here. Here, this is a high slew rate, this is a limited slew rate. High slew rate when there is the maximum rate of change in voltage with respect to time. So if I limit that slew rate, nothing but we can reduce the inductance. And the second thing here, if I reduce the slew rate, it will affect the propagation delay. Means there is an increase in the propagation delay. Thereby, again reduces the clock rate. So by this, we can reduce the inductance, thereby we can increase the signal integrity. So this is about how signal integrity is important to transmit the information from source to the destination. Okay, a simple explanation regarding signal integrity. In the next video, we will discuss how to overcome with overshoot, undershoot and ringing transmission line effects and differential signaling. Thank you.